Okay guys, so let's have a look at question 8. We're going to do part A. We've got a uniform lamina. There's a hole cut out of it. It's a rectangle here. This hole is cut out here. The radius of the circle, better put that in, is 3 centimeters. So let's just go back to the question, have a quick look at it on the actual paper itself. Here it is here. So I've just drawn in the picture myself. Here's all the dimensions listed in the question. Described in words here, and here's the picture. The problem is calculate the distances of the center of mass of the lamina from AD and AB. So we're going to take moments about AD and moments about AB using the fact that we've got a uniform lamina. So the weight of these objects is proportional to the actual areas. So we can use the areas as a representation of the weights, can't we? Give your answers correct to 3DP. So let's have a go at part A then, shall we? So I'm going to take moments. You'll notice I put the moments here. The first one about AD, I'll find out the distance of the center of gravity of the lamina that we have by doing that. And about AB, we'll get the vertical distance here. So the first thing about AD then. So basically, if I was thinking of moments, the rectangle as a whole, if I think about that rectangle has area 10 by 12. So what we should have is that 10 by 12 is the area times by its center of mass, which is a distance, because it's a rectangle, would be 5, wouldn't it? So that whole shape would equal the circle. So the area of the circle is pi r squared. Yeah, and it's 3 squared, so I better put that in, haven't I? And 3 squared is 9. So I'll still write pi r squared. I've managed to do 3 again, which is clever. So let's try once more. Pi times r squared. There we are. There's the area of the circle. Now its center of mass is a distance 4 centimeters, it says, away from the edge AD, so that'll be times 4, won't it? Plus, and then we're going to have the actual lamina distance, which we don't know its center of gravity. We know that its area is going to be 120 minus the 9 pi. 120 minus 9 pi times its distance, horizontal distance, we'll call x. So this gives then, we've got 120 times 5, which is 600, equals 9 pi times 4, which is 36 pi, plus 120 minus 9 pi times x. So now I'm going to read that from right to left. So x equals then, it'll be 600 minus the 36 pi. So I've moved that over there, and then I'm going to move that from, after I've done that, move that from times to divide. There we go. So x equals, so what have we got then? Let's tap that in the calculator. So we've got 600 on the top, minus 36 times pi, and the top value will equal that number there. So I've worked that out. Divided by the bottom now, 120, bracket 120 minus 9 times pi, close the bracket, equals 5.308 to 3dp, 5.308, 5.308, and that's centimeters. So that's the x distance of the center of gravity of the cut out piece of lamina. Now we'll apply moments about AB, then same thing again really, and we'll look at moments around AB. So here, let's do that then. The whole rectangle would be, again it's 10 by 12, is the area, times by the vertical distance of the center of gravity, which would be halfway up, which would be at 6. That would equal the lamina, which we know to be this, 120 minus 9 pi, times its center of gravity, which is y. Yeah, so that would be that, plus the circle, which is pi r squared, which was 9 pi, put that down straight away, times its distance of centre of gravity, which is 7. So what have we got here then? Well, we're going to have, let's leave that there, 120 minus 9 pi times y. And what we're going to have, that's on the right, so I'm reading it from right to left. It's 120 times 6. Well, 6 12 is 72 times 10 is 720, isn't it? 6 12 72. 72 times 10 is 720. Move this over to be with that, so it's going to be a minus. And I'm reading from right to left, aren't I? 9 7s is 63 pi. So then, now we can move this times to divide on the other side. So y equals 720 minus 63 pi divided by 120 minus 9 pi. More than one term top and bottom, so if you want to be extra careful, put brackets. Let's get our calculator and let's type it out, shall we? Okay, we got 720 minus, I'm just going to work out the top number, minus 63 times pi equals, we got that. So there's our top number, divided by brackets. The whole thing underneath, I need a bracket, don't I? 120 minus 9 times pi. Shift pi. Close the bracket. Okay, equals 5.692, because the 7 rounds the 1 up to 2. 5.692 centimeters. So there we are. There's the centre of gravity of the laminate with the rectangle with the circle cut away from it. X distance of 5.308. The y distance is 5.692. Let's go back to our question to make sure we've answered it correctly. Calculate the distances of the centre of mass of the lamina from AD, which we did, and AB, which we did there. Give your answer to correct at 3 decimal places, which we did. So that's the first part done then, AA. So that's great, good. Let's go on to the next part now.